as I'm sure you'll be aware, the 6 markers follow a fairly similar routine, each one that you do. So you'll break it down into a level 1, 2 or 3 answer, and then you'll be given a mark somewhere within there. Now, I'm going to go through the information first of all, and then come back to see how we can break this down and simplify it a little. In this particular question, there were 3 areas that needed to be covered. We needed to get some correct deductions from the graph. We needed to know what the optimum temperature would be and why, and we needed to know what the optimum pressure would be and why. And you can see here deductions from the graph I've already jotted down. We can see that the yield goes up as the temperature goes up, but we can see that that's only up to a certain point. Eventually that stops. And we can see that yield decreases as the pressure increases. So we've got all of that from the information that's provided. If we then go to the optimum temperature and the explanation, this is taking us back to something that we're hopefully familiar with from GCSE. Higher temperature has got higher energy costs. So you are getting that balance between how much you're going to spend and how much profit you're going to make from the materials that you're making. There's also the fact that the temperature stops having an effect after a certain point, so it would be pointless going any higher. And then from there, what they would also want you to do is choose the optimum temperature, and the range that was acceptable was somewhere between 780 and 880. So just for clarity, that's where it's starting to level off in figure 1. In terms of the optimum pressure and explanation, well, we can see here that we have a compromise once again. It might be that we do go to a lower pressure. We know a lower pressure gives us a higher yield, but a lower pressure might bring the rate of reaction down far too much for it to be feasible. So we have to make that compromise. And again, if we're looking for an optimum pressure, the acceptable answer here was somewhere within the range of 1,000 and 2,000 kilopascals, the higher end of the range on the graph that's provided. Now what I've done here is gone through to look at everything that we can take from the actual graph. So everything that's highlighted in green is right here on the page with you. It's there for you to take. The information in yellow is where you then need to apply your knowledge, and you need to put your awareness of Equilibria onto the page as well. In terms of the breakdown, in very simple terms, and it's more detailed in the actual mark scheme, but to get into level 3, 5 or 6 marks, all of the stages need to be covered effectively. That will often mean you've got to get 2 out of 3 of the things that are listed here. To get a level 2, 3 marks or 4 marks, you can have attempted all 3 of them, but with gaps, so more than 1 gap, or 2 of them can have been covered effectively. And to get a level 1, 1 mark or 2 marks, then you would need to have covered 2 of the stages to some degree, or 1 stage effectively covering all of the key details. Now again, if we break that down here, that I've got all green for the deductions from the graph. That, if you do it properly and give that information, immediately takes you into a level 1. So if you then attempt to talk about the optimum temperature or the optimum pressure, that's moving you up into the higher levels already. So you don't have to add a huge amount of chemistry value to be able to start to pick up marks on this exam. Obviously, you're aiming to get the full 6. To do that, it also needs to be written in a logical way. It needs to flow, and you need to be showing evidence of the correct use of scientific terminology. So getting the right keywords in there is always a winner.